Hello, students. Um, this simulation will help you to understand Newton's second law of motion, or to explore Newton's second law of motion. We have a set of questions for us to answer. There are 4 questions. I'm going to go through each question and guide you through on how you can use the simulation to answer those questions. I'll try to be as brief as possible, and I'm hoping that you can do more on your part. First of all, we need to go through question number 1. Question number 1 is asking us to find out the kind of motion we may have when an object is moving and then the net force on it is 0. So we have to make sure that there is a net force of 0 on the box. So first of all, you're going to click reset, making sure that the simulation is the way it came. And then make sure you click on ice so there's no friction. This is the normal force, and this is a gravitational pull. The net force right now is 0. And then you can push the box, the beginning here, somewhere close. All right. And then we need to make sure that the box is moving. So we need to give it a nudge or a push and then release. So I'm going to do that. So you push it. Once you pick up some speed, you can release. Once you release, you have achieved a situation whereby the box is moving with a 0 net force. Then you can describe the motion. I'll stop this one. Before I go to part 2, I'm going to reset everything. And I'll try to take the box, the beginning somewhere here. So I should start pushing from there. I'll make sure that I am on ice here. The next question asks me that what will happen if I consistently push the box without releasing? In other words, what will happen to the speed of the box if I give it a net force that is not 0? So I will push the box like this, and I'll keep it there and observe the motion, and then answer the question. Okay, all right. We are going to go to question number 3. Question number 3. Before that, let's reset everything. Reset here. And then we have to drag the box closer here and put it on ice. Question number 3 is asking us to compare how fast the box moves, but we have to compare with the amount of pushing. So they say, let's try to compare maybe 1,000 newtons versus 5,000 newtons, and you see how the box speeds up. So you can type here 1,000 newtons and you play. Once you play, the box will start moving with a net force of 1,000 newtons. So like that. You can observe the motion carefully, and then you're gonna compare that with, you have to compare it with pushing using a larger force. So you might want to put 5,000 here and play this one. So you are going to compare how fast the box is moving. Compare the 1,000 newtons versus 5,000 newtons. All right, so let's reset and move on to question number 4. So reset. Yes. Then I like to start the box somewhere here, here. And then I put the box on ice, no friction. And then look at the question. So the question is asking me that if I push this box compared to pushing a heavier box like the refrigerator here, how the box speed up? If we compare the two speeding up processes, how do they compare? So that's what you have to do. So to do that, we need to push consistently. In other words, we have to choose some force that we can use. So maybe I can choose I can choose 5,000 newtons. That will be the force I'm going to push both to the small crate and also to the refrigerator, which is 200 kilograms. I have to keep the force the same. All right, so I'll start with a small crate and then I'll observe the acceleration. And then I can say, okay, I saw that, but then let's try the refrigerator. So same amount of force, let's try the refrigerator here and then see how it accelerates. So you play it and you observe the acceleration. Okay, so you need to carefully observe the two kinds of accelerations. Oh, sorry, I should say the speeding up processes, and then answer the question number 4. I'm using this term acceleration interchangeably with speeding up. You can also find out how we're using the terms in our textbook. If there is any question, please let me know. I'm sure you'll be able to find this simulation useful as you try to understand Newton's second law of motion. Thank you so much for listening.